Hello, welcome to the first ever question in my channel of the October-November 2020 series. So this is October-November 2020 and paper 1-1, and the question number is 36. And this question is, as you can see from the diagram, it is concerned with the chapter current electricity. So I have picked a very tricky question in the very beginning. Tricky, let us not say tricky, it is rigorous actually. So it says three identical lamps L1, L2 and L3. That means they have got equal resistances. So I like to name the resistances R as well as R. So since they have been declared as identical, are connected to a battery with a negligible resistance. So what happens to the brightness of lamps L1 and L2 when the switch S is closed? So that means this switch S is determining whether this L3 is into the circuit or not. So initially S is open. So S open means that this L3 is useless. So now our circuit will just be like this, So let me draw it in a voltage divider form. So this is the source. From here I have this first lamp. First lamp is L1, and then I have got the second lamp. This is L2, like this. So to know the brightness, I have to know how much power it is consuming, power 1 and power 2. So for that I require, this is E, its resistance is R, and its resistance is R. So first let me find what is the potential difference here, and what is the potential difference here. This is V2, this is V1. So this V2 should be equal to, or V1 should be equal to, we can do anything. So V2 is equal to, according to the voltage divider formula, equal to the resistance here divided this resistance plus this resistance, which is R plus R, into this E. That's equal to R by 2R into E. R cancelled, which is equal to E by 2. So here V1 also will be the same. So V1 also will be equal to E by 2 because they are equal resistors. Then the power consumed by 1 will be, so power 1 will be equal to, so let me write here, power 1 is equal to the potential difference square by its resistance. So it's equal to E by 2 whole squared divided this R equal to E squared by 4, and then R equal to E squared by 4R. So this gives us power 2 is also equal to E squared by 4R. So first what we did was we got the formula for the power consumed by each of the lamps L1 and L2, and both of them are consuming same power, which is equal to E squared by 4R. So let's take care of this thing and this thing. Now we close the switch. When the switch is closed, the circuit will be like this. So now the circuit will be, so this is the source, I do like this. So this is lamp 1. Then I have got a parallel arrangement of lamp L2 and L3. So let me do it like this. So this is one lamp here, and this is another lamp like this. So my circuit is somewhat like this. This is L1, this is L2, L3, L2, L3. Here it is V1, let's say like this, V1, and from here this is new V2. So here we have got L3, but if I say V3 and V2 will be equal. I can give any name there. So this is R, and both of these things are R as well as R. Now here let's find V2 and V1 separately. The total resistance from this point to this point will now be R by 2 because it's parallel. So in parallel combination, the resistance will be R by 2 if it is R and R. So I will have The resistance here is R by 2. So V2 should be equal to, the resistance here is R by 2. So it is R by 2 first, then R by 2 plus R. R by 2 is this resistance, R is this resistance into this E, equal to R by 2. This is 3R by 2, R by 2, and then E. So R by 2 and R by 2 gone, only 3 here. So it is E by 3. V2 equal to E by 3. So if V2 equal to E by 3, then V1 should be equal to, since this thing is E, this is E by 3, it should be equal to 2E by 3. I can just know it by means of general discussion, or I can determine the value as well. So anyhow, it will be 2E by 3. So therefore, the new power 1 should be equal to V1 square by the resistance, equal to 2E by 3 squared by R, equal to 4E squared by 9, then R, equal to 4E squared by 9R. Then P2 is equal to V2 squared by, so P2 means the power consumed by this lamp, so its resistance is simply R. That's equal to, V2 is the PD across this lamp. The PD here and the PD here are same. So that's why the PD here should be equal to this thing, V2. So V2 squared by R. So V2 is as given here, E by 3 squared by R, equal to E squared by 9 by R, equal to E squared by 9R. Now for lamp L1, the power consumption has changed from, so initially it was E square by 4R, E square by 4R to 4E square by 9R. So this E square by 4R is 0.25 to this 4 by 9 is, let me do a calculation. I am slightly weak in this mathematics. One of the comments that I received was, you use a calculator even for small mathematics. So in fact, yes, my habit has been spoiled. So 4 divided 9 is equal to 0.44. So it is 0.44. That means this lamp will be brighter. It is consuming more power now, using more power. So this lamp should be brighter. So brighter means, so choice number C and D, they disqualify. C and D disqualify. Then for lamp L2, our power is going from, power is E square by 4R, initial was E square by 4R. It is going to E square by 9R. So that means it is from 0.25 till it is going to 1 divided 9, equal to 0.11. So that means that this L2 will be dimmer. It will be glowing dimmer. So the choice should be brighter dimmer. Choice should be B. And so A also is the wrong choice. B is the correct choice. So this was the first ever question of this year's October-November papers, and I chose a tricky one, and definitely it was, if not tricky, it was rigorous. Thank you.